Hello everyone. In this session, we'll be learning about amplifiers, its gain, characteristics of an ideal amplifier, and different classification of amplifiers. So the question is, what is an amplifier? Amplifier is the generic term used to describe a circuit which produces an increased version of its input signal. The process of increasing the signal strength is called amplification. To understand how much the input signal has been amplified or how much an amplifier amplifies the input signal, a factor called gain is considered. The amplifier gain is simply the ratio of output divided by the input. The gain has no units as it's a ratio, but in electronics it is commonly given a symbol A for amplification. The gain of an amplifier is simply calculated as the output signal divided by the input signal. Depending upon the input and output signal measured, the gain can be classified into three types, which are voltage gain, which is represented as AV, and current gain, which is AI, and power gain as AP. To find the voltage amplifier gain, the output voltage is divided by the input voltage. And to find the current amplifier gain, the output current is divided by the input current. And to find the power amplifier, we can simply multiply the voltage gain with the current gain. And also, power gain can be also obtained by dividing the power obtained at the output with the power obtained at the input. The power gain or the power level of the amplifier can be expressed in decibels. Bell is a logarithmic unit of the base of 10 of measurement which has no units. Since bell is too large of a unit to measure, it is prefixed by deci, making it decibels. A decibel is only 1 by 10th of bell. To calculate the gain of the amplifier in decibels, we can use the equations like voltage gain or AV is equal to 20 log AV, and current gain would be in 20 log AI, and power gain would be 10 log AP in uh, in decibels. Note that the DC power gain of an amplifier is equal to 10 times the common log of the output to the input ratio, whereas the voltage and current gains are 20 times the common log of the ratio. However, the 20 dB is not twice as much as the 10 dB because of the logarithmic scale. A positive value of dB represents a gain and a negative value of dB represents a loss within the amplifier. Let us now look at the characteristics of an ideal amplifier. The amplifier gain should remain constant for varying values of the input signal. Number two, the gain is not affected by frequency. That is, the signals of all frequencies must be amplified by exactly the same amount. The amplifier's gain must not add noise to the output signal. It should remove any noise that already exists in the input signal. The amplifier gain should not be affected by changes in temperature, giving good temperature stability. The gain of the amplifier must remain stable over a long period of time. But in real life, it is far-fetched. For a transistor to act as an amplifier, it should be properly biased. Now let us focus on how a transistor works as an amplifier. A transistor acts as an amplifier by raising the strength of a weak signal. The DC bias voltage applied to the emitter base junction makes it remain in forward bias condition. The forward bias is maintained regardless of the polarity of the signal. The below figure shows that what a transistor looks like when connected as an amplifier. The low resistance in the input circuits lets any small change in the input signal to the result in an appreciable change in the output. The emitter current caused by the input signal contributes the collector current, which when flows through the load resistor RL results in a large voltage drop across it. Thus, a small input voltage results in a large output voltage, which shows that the transistor works as an amplifier. Amplification, when done without any loss in the components of the signal, is called as faithful amplification. Or, in other words, faithful amplification is a process of obtaining complete portion of the input signal by increasing the signal strength. Let us now look into the key factors for faithful amplification. To ensure faithful amplification, the following basic conditions must be satisfied. Number one would be the proper zero signal collector current and minimum proper base emitter voltage at any instant and minimum proper collector emitter voltage at any instant. The fulfillment of these conditions ensures that the transistor works over the active region having input forward bias and output reverse biased. To understand the characteristics of faithful amplification, we will be looking into each one in detail. Now, in order to understand this, let us consider the figure in which VBB is absent. Now, the base emitter junction is forward bias and the collector emitter junction is reverse bias. When a signal is applied at the input, the base emitter junction of the NPN transistor gets forward bias for the positive half cycle of the input and hence it appears at the output. For negative half cycle, the same junction gets a reverse bias and hence the circuit doesn't conduct. This leads to the unfaithful amplification. Now, let us see what happens when VBB is introduced in the circuit. The magnitude of this voltage should be such that the base emitter junction of the transistor should remain in forward bias even for the negative half cycle of the input. When no input signal is applied, a DC current flows in the circuit due to VBB. This is known as zero signal collector current or IC. During the positive half cycle of the input, the base emitter junction is more forward bias and hence the collector current increases during the negative half cycle of the input and the input junction is less forward bias and hence the collector current decreases. Hence both of the cycles of the input appear in the output and hence faithful amplification is obtained. Hence, for faithful amplification, proper zero signal collector current must flow. The value of zero signal collector current should be at least equal to the maximum collector current due to the signal alone. The minimum base to the emitter voltage VBE should be greater than the cut-in voltage for the junction to be forward biased. The minimum voltage needed for a silicon transistor is around zero point 0.7 voltage and for a germanium transistor is around zero point 0.5 voltage. If the base emitter voltage VBE is greater than this voltage, the potential barrier is overcome and hence the base current and the collector current increase sharply. Hence, if VBE falls low for any part of the input signal, that part will be amplified to a lesser extent due to the resultant small collector current, which results in unfaithful amplification. To achieve faithful amplification, the collector emitter voltage VCE should not fall below the cut-in voltage, which is called as knee voltage. If VCE is less than the knee voltage, the collector base junction will not be properly reverse biased. Then the collector cannot attract the electrons which are emitted by the emitter and they will flow towards the base which increases the base current, thus the value of beta falls. Therefore, if VCE falls low for any part of the input signal, that part will be multiplied to a lesser extent, resulting in unfaithful amplification. So if VCA is greater than E voltage, the collector base junction is properly reverse biased and the values of beta remain constant, resulting in faithful amplification. Let us now try to understand the classification of amplifiers. Amplifiers are classified according to many considerations. Now let us look into the classification based on number of stages. Depending upon the number of stages of amplification, there are single stage amplifiers and multi-stage amplifier. For a single stage amplifier has only one transistor circuit and which has only a single stage amplification. And for a multi-stage amplifier, there are multiple transistor circuit which provides multi-stage amplification. Classification based on output of the amplifier. Depending upon the parameter that is amplified at the output, there are voltage and power amplifiers. Voltage amplifier, the circuit increases the voltage level of the input signal is called a voltage amplifier. And if the circuit increases the power of the input signal, it is called a power amplifier. Depending upon the magnitude of the input signal applied, they can be categorized as small signal as well as large signal amplifiers. For small signal amplifiers, when the input signal is so weak that to produce a small fluctuation in the collector current compared to that of the quiescent value, the amplifier is known as small signal amplifier. And large signal amplifiers, when the fluctuation in the collector current are large, that is beyond the linear portion of the characteristics, the amplifier is known as a large signal amplifier. Depending upon the frequency range of the signals being used, amplifiers are also classified as audio amplifiers and radio amplifiers. In audio amplifiers, the amplifier circuit that amplifies the signals that lie in the audio frequency range, that is from 20 Hz to 20,000 kHz frequency range, is called as audio amplifiers. And power amplifiers are circuits that amplifies the signal that lie in a very high frequency range, and it is called as power amplifiers. Amplifiers are also classified depending upon the mode of operation. There are Class A, Class B and Class C amplifiers. In Class A amplifiers, the biasing conditions in Class A power amplifier are such that the collector current flows for the entire AC signal applied. And in Class B amplifier, the biasing conditions in Class B power amplifier are such that the collector current flows for half of the cycle of the input AC signal applied. And the biasing conditions in Class C power amplifiers are such that the collector current flows for less than half cycle of the input AC signal applied. And the Class AB power amplifier is one which is created by combining both Class A and Class B in order to have all the advantages of both the classes and to minimize the problems they have. Depending upon the method of coupling, one stage to the other, there are RC coupled, transformer coupled, and direct coupled amplifiers. A multi-stage amplifier circuit that is coupled to the next stage using a resistor and capacitor combination can be called as an RC coupled amplifier. A multi-stage amplifier circuit that is coupled to the next stage with the help of a transformer can be called as a transformer coupled amplifier. And a multi-stage amplifier circuit that is coupled to the next stage directly can be called as a direct coupled amplifier. Now, depending upon the type of the transistor configuration, there are CE, CB and CC amplifiers. The amplifier circuit that is formed using a CE configured transistor combination is called a CE amplifier, and the amplifier circuit that is formed using a CB configured transistor combination is called a CB amplifier. The amplifier circuit is formed using a CC configured transistor combination is called a CC amplifier. We will be dealing with all these configuration in detail in the coming classes. Thank you.